to be taking a look at network endpoint monitoring, specifically Osquery, the basics. This lab has been provided to us and narrated by John Hammond. Shout out to him, much appreciated. Let's go ahead and move forward here. Osquery is an open source agent created by Facebook in 2014. Converts the operating system into a relational database. Allows us to ask questions from the tables using SQL queries like returning the list of running processes, a user account, created on the host, and the process of communicating with certain suspicious domains. It's widely used by security analysts, incident responders, threat hunters, etc. Osquery can be installed on multiple platforms, Windows, Linux, Mac, and FreeBSD. Learning objectives, we're going to go over what is Osquery, what problem it solves, entering interactive mode, how to use the interactive mode to interact with the operating system, and how to join two tables together to get a single answer. Let's go ahead and continue here. As usual, it's going to ask us to launch the lab. It will provide us with a Kali Linux virtual machine. We'll go ahead and load that up now.
And there are a whole lot of ways to interrogate data and information from an endpoint, a device, from a machine, from a computer. And one of the coolest ways to do that is to treat the whole operating system like a database. In this video, we're going to play with it. I want to showcase Osquery within a Tryhackme group.
Alright, so it looks like we're just going to go. Looks like we'll just go over the basics of the thing here again. Yes. And then we're going to go ahead and talk about
let me take a look at
different labs that are provided on the platform, and below you can see security information and event management, forensics and incident response, as well as phishing.
You can also zoom into SIEM, whether it's Splunk, whether it's ELK. You can get into some other DFIR, digital forensics and response, whether or not to do artifacts, other tools, memory forensics, yada, yada, yada. Anyway, I'm sorry, I'm rambling.
Yada, 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 for sure. I definitely agree. They do their best to offer as many software packages and labs as possible. It's a very good thing. It looks like he's just going to be doing a basic walkthrough of the lab.
Drill down as to how is that table made, what fields or data or information you actually include in that table. Well, we can use .schema.
Okay, let's go ahead and get started. Alright, we've managed to start the lab here. Let's go ahead and continue here. Click on the PowerShell terminal pinned to the taskbar and enter Osquery I to enter interactive mode. Okay. Here's PowerShell. We'll type in Osquery I. We'll start the interactive mode here using a virtual database here. You're now in the Osquery DB. One of the ways to interact with Osquery is by using the interactive mode. Open the terminal, run Osquery I. To understand the tool, run .help command in the interactive terminal. .help is going to provide us with some options here. All tables, we can select from all tables. Bail on and off, stop after hitting an error. Connect path, connect to an Osquery extension socket. Disconnect, of course, will disconnect from the socket. Echo on and off to turn on and off echo command, exit, features, and etc. You can also print strings. The value of a string shown creates statements for a specific schema, as well as list the name of tables and types of tables. Scrolling down here, we can see the list of the tables that can be queried using the .tables meta command. For example, if you wish to check what tables are associated with the processes, you can use the .tables process. Using a virtual DB, here it's going to show us some databases, ARP cache, data packages, okay, background activities. To list all tables with the term user in them, we will be using tables user as shown below. Osquery using virtual DB, we're going to do table user here, table user. We can see we have a few groups here, user groups, user SSH keys, user assets, and users. Understanding table schema. Table names are not enough to know what information it contains without actually querying it. Knowledge of columns and types, known as the schema, for each table is also helpful. You can't list the table schema with the following meta command, .schema table name. Right, so if we wanted to check, let's see here, .schema of users, we're able to do that, create users. Different username tags. The above result provides column names like username, description, PID, followed by respective data types like big int, text, integer, and etc. Let us pick a few columns from the schema and use SQL query to ask Osquery to display the columns from the user table following the syntax. SQL query syntax is going to be selecting columns 1, 2, and 3 from the table below. And here we can go over disable mode or display mode. Let's go ahead and start answering the questions. How many tables are returned when we query table processes in the interactive mode? All right, let's go ahead and enter the schema process here. Check how many tables are returned. If it wants to work. All right, well, using the .table process, we're able to see that there is 3 tables returned here. Let's go ahead and move on. Looking at the schema of the processes table, which column displays a process ID for the particular processes? Done that above, .schema process. And the answer is going to be the PID. Examine the .help command. How many outputs display modes are available in the .mode command? All right. Help. Let's see. Check out the .mode. Set the output mode where mode is one of CSV, column, line, list, or pretty. 1, 2, 3, 4, and 5. It was 5 display outputs. Moving forward, we're going to take a look at the schema documentation. For this task, go to the schema documentation, the Osquery version 5.5.1. Latest version. Documentation looks like the image shown below. We can see 106 tables. You can see it's compatible with the Windows operating system. See a different list of columns, executables, paths, descriptions, install times, types, and etc. Let's take a look at the breakdown here. You can find some important information about the schema documentation. The drop-down lists various versions of Osquery. Choose the version of Osquery you wish to see schema tables for. The number of tables within the selected version of Osquery in the above image, 106 are available. The list of tables is listed in alphabetical order. For a selected version, the same result we get with the .table command in interactive mode, okay? Name a table, brief description, yada, yada, yada. All right, let's go ahead and take a look down here. You can also see different platforms and the compatibility. Once again, moving on to the questions. In Osquery version 5.5.1, how many common tables are returned when we select both Linux and Windows operating system? All right, we've made our way to the Osquery 5.5.1 version here. Getting some different tables, but that's all right. We're we're going to select the Linux and Windows. Is that the question, right? How many both Linux and Windows on the operating system? We have a total of 56 tables here. All right. In Osquery version 5.5.1, how many tables for Mac OS are available? We'll go ahead and switch this to only Mac. Looks like we have 180 tables. In the Windows operating system, which table is used to display the installed programs? We'll go back to the site here, and we are going to switch to Windows. All right, so the next question is asking us in the Windows operating system, which table is used to display the installed programs? Now, I don't know how long we can scroll down here for, but it looks like a lot. So instead of doing that, let's just go ahead and hit Control F. And we're going to type in programs. Oh, look, it's also on the left-hand side if we were to scroll down here. Programs represents products as they are installed by Windows installer. Product generally correlates to one installation package on Windows. Some fields may be blank as Windows installation details are left to the discretion of the product author. So that's going to be the answer here. In Windows operating system, which column contains the registry value within the registry table? Let's go ahead and go back. We will search for registry again here. Search with Control F, search for the keyword, and go take a look at the question here. Which column contains a registry value? That would be data. Okay. Awesome. Let's go ahead and move on to task 5, creating SQL queries. The SQL language implemented in Osquery is not an entire SQL language that you might be accustomed to, but rather it's a superset of SQLite. Realistically, all your queries will start with a select statement. This makes sense because with Osquery, you're only querying information on the endpoint. You won't be updating or deleting any information or data on the endpoint. There is an exception to this rule. Using other SQL statements such as update and delete is possible, but only if you're creating runtime table views or using an extension if the extension supports that. Let's go ahead and take a look at exploring installed programs. If you wish to retrieve all information about the installed programs on the endpoint, first understand the table schema either using the .schema programs command in the interactive mode or the documentation here. We'll go ahead and open this up quickly. Bring us back to the web page we were at before. In the above example, limit was used, followed by the number to limit the results to display. Cool. All right. You can also count, where clause. Optionally, you can use where clause to narrow down the results turned based on specific criteria. Equal sign, not equal, is greater or less than. Between the range, we have a like for wildcard searches. And we can also search for matching wildcard rules, the percentage symbol, percentage ABC, etc. You can also use joining tables. This is a function. And this was actually going to join two tables based on the column that is shared by both tables. Let's go ahead and take a look at the questions. Using Osquery, how many programs are installed on this host? Okay. Let's go ahead and select count on programs to see how many there is. Looks like we have an answer, a total answer of 19 programs installed on the host. Using Osquery, what is the description for the user James? Okay. All right, what is the description for the user James? We're going to use the where clause, and we're also going to search for description here. What is the description for the username? So we will select description from users where username is equal to James. Does not like us. Alrighty. Selecting from users where username is equal to James, we're able to see a couple tables here. However, it's asking us the description. What is the description? Let's go ahead and change our search parameter here. What we're going to do, remove the asterisk, and we'll just use description. Description is going to be creative artists. When we run the following search query, what is the full SID of the user with RID 1009? Query, select path, key, name from registry. All right, let's go ahead and type this in. We'll run the full command here, run the following search query. What is the blah, 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 blah. All right. Let's go ahead and find the SID or security identifier of the user ID 1009. So that's going to be, here we have 1009. And that is looking like the SID number right there. Not sure if it's going to allow us to actually copy that. It will. All right. So, interesting. This would be the full SID. There we go. That's the full SID, security identifier. Let's go to the next question. When we run the following search query, what is the Internet Explorer browser extension installed on the machine? Query, select from IE extensions. We forgot to. Microsoft URL search hook, HQ users. Okay, what is the browser extension? .dll, that's going to be it. Here. Alright, so select IE extensions. That is going to be from the C drive here, Windows System 32, ieframe.dll. After running the following query, what is the full name of the program returned? It's going to search for programs similar to Wireshark here. Let's go ahead and select name, install location, programs where name is like that of Wireshark. We're going to get the full name and the version, right? So we're going to get Wireshark's 3.6.8 64-bit. Probably won't need the 64-bit on the answer here. All right. Challenge and conclusion. Now that we've explored various tables, learned how to create search queries and ask questions from the operating system, it's time for a challenge. Use Osquery to examine the host and answer the following questions. Which table stores the evidence of process execution in Windows OS? Which table stores the evidence of process execution in Windows OS? I have no idea. So what we're going to do is go to the documentation here, and we're going to search for process execution, similar as we did before. If I can read process executions here, we got 4 matches total. So process events table. No? Okay. All right, going back to here, it's not going to be process events, it's actually going to be the registry key. If I can spell correctly. All right, navigating to the documentation page and typing in registry here at search F, we can find user assist. User assist registry key tracks when the user executes an application from the Windows Explorer. One of the users seems to have executed a program to remove traces from the disk. What is the name of that program? All right, since the last answer to the question was user assist and speaks about evidence of process execution, looking at the second question here, we're also expected to answer a question about process execution. So let's go ahead and see all the processes from the user. So what we're going to do, we'll type select path from user assist. I don't like that. Okay, but hold on. All right, looks like I forgot a semicolon here. Let's go ahead and type that in. Select path, syntax error, select near, select path from user assist. Gonna select path from user assist. We can see a lot of information here. Let's see, control panel, Cortana, MS Paint, Notepad, CMD, etc. What is the name of the program used to remove traces from the disk? All right. One of the users seems to have executed a program or traces from the disk. What is the name of that program here? After using the select from user assist to list all the programs, we have we're able to see mspaint.exe, Notepad, CMD, Osquery, and the whole lot, right? We can also see a disk wipe.exe. It's been executed. That's going to be the answer. Create a search query to identify the VPN installed on this host. What is the name of the software? Alright, create a search query to identify the VPN installed. Alright, create a search query to identify the VPN installed on this host. What is the name of the software? We're going to use wildcard here to search for programs like. Start with the select path for programs where the name is like. We'll add the wildcard. Search VPN specifically. No path. Okay. Forgot our asterisks here. Alright, create a search query to identify the VPN installed on this host. What is the name of the software? We're going to select for programs where name is like. We'll add the wildcard here. Sit that error, okay. Cool. What is the name of the software? Click Proton VPN. There we go. How many services are running on this host? All right, so let's go ahead and check the amount of services running here. We're going to use the count query here. So you're going to select count and services. So we have a total of 214 services running. Table auto exec contains a list of executables that are automatically executed on the target machine. There seems to be a batch file that runs automatically. What is the name of the batch file with the extension .bat? Go ahead and search for that. Just go ahead and select name from, I wish I could type better, whatever. Go ahead and do a select name from auto exec. This is going to take a little bit of time, no problem. All right, here we're able to see a long list of executables. We're looking for one that ends in .bat. We have batstartup.bat here. That's going to give us the answer. Let's go to the last question. What is the full path of the batch file found in the above question? Last in the list. Okay, we're going to search the full path of this executable here. All right, let's go ahead and enter select path from auto exec, as we have 2 seconds ago, where name is equal to bat startup.bat. This is going to take a while as well. All right, seems we have the full path here. We've got actually 2 different paths, program data, Microsoft Windows, but we're actually going to go with the user's James app data. Startup.bat. And we have completed the Osquery lab. If you like this walkthrough, we're able to learn some things, feel free to like, subscribe, and comment.